So let's talk about calculating standard deviation for group data. This is a continuation video from the earlier series. We are into part 5. Hopefully this will be the concluding series, maybe one more. I'm not sure. Let's see how this goes. But check out my prior videos on part 1 through 3, 4 before you get into this. And we are trying to solve the exam problems on this topic. And like I said, we are focusing on type 3 for the last few parts, just on this type, which is including of variance, standard deviation, and coefficient of variation. And within that, one of the variance that we are about to tackle, which usually comes for 6 marks, is how to calculate the standard deviation and hence the CV for group data. And you should know by this time what is group data, because we have covered this extensively across different videos, and we started this from the topic of mean. So do a quick recap if you're not sure, but other than that, let's check it out. All right. So we're just focusing on this one variation, which definitely comes for 6 marks. It will come for sure, so we cannot miss. And typically you will have to calculate more than one value. You might have to calculate mean, you might have to calculate standard deviation, the second value, and you might have to calculate the coefficient of variation, the third value. That's how you need to calculate. And the data will be in a group format where you will have class intervals. And we have seen the ungrouped data in the previous episode. We'll have the same rules and procedure to calculate the required ask, but there are some nuances on how to think about group data of calculating midpoint and stuff like that. So we'll be talking about that. So whenever I talk about group data, you should know that we have to first calculate the mean using the midpoint formula. And in this kind of variation, typically there are 3 problems. There are only, for the last 4 papers, there are only 3 types of problems. 2 of them are of similar nature, different numbers. For example, if you take this problem, and if you take this problem here, these are the typical 2, I would not say types, same type, same variation, different numbers. So it will be there. So I have to just solve one so that you can understand the second one. And this one, this particular baby, if you see, this has come 3 times in the last 4 papers or 5 papers, same numbers. If you see here, 3 or 4 times the same number has come. So maybe you might want to focus on this particular example more importantly, because this looks like there is a pattern and there is a small variation. There's a tricky one over here. I'll be taking that in the last episode, or towards the end, either in this episode, or I might put a separate episode. This is the trickiest one where we need to pay attention to certain things. But let's knock off the easy ones first. Let me take these 2 examples over here. The winter 2019 problem and the one that repeats quite often, and then we'll move to the trickiest one. All right, let's get started. Okay. So whenever we get a problem, either for group data or ungrouped data, where we have been asked to find either standard deviation SD or CV, coefficient of variation, or even variance as a parameter, whenever we get that, we should always remember few things in mind, and those are the tips that we need to remember for this kind of variation. Mean, SD, and variance all are related. Okay, one is derived from the other. First we need to calculate mean, then we need to calculate mean, and based on that we can calculate SD and variance. Always remember that. Okay. And so what does it mean? What does it imply? We need to calculate the mean always. That's the first step. Okay. And whenever the data is grouped, we need to use or find the arithmetic mean, the average arithmetic mean, using the midpoint formula. So that should be the another point to remember. And the way you calculate this is, you remember this MVS trick, where you always calculate the mean first for M for mean, then you calculate the variance, regardless of they're asking you to find the variance or not. For example, if you see this problem, they are not asking you to find the variance, but we know the standard deviation is computed from variance, and hence we'll find the variance. That's an easy method. And then we'll find SD, and then finally we'll find CV. That's the sequence you find. Okay, so MVS, mean, variance, and standard deviation. Okay, always use a table format like we do for statistics to put your calculations. It's very easy. And whenever they give you any abstract problems, meaning that they're just talking about class and frequency and using jargons without giving you a context, always visualize in your head and give it a context or personify that. For example, I would say, okay, this means in frequency they're talking about the number of students, and in this class interval they're talking about the marks scored by the students. So when you put that in a perspective, give it a real example, you'll be able to relate what they're asking and how to think about that. It always helps. So always keep that in your head behind the scenes so that you can solve it very easily. And the standard 5 steps I put how to calculate the standard deviation. We will kind of correlate this when we solve the problem. Okay. So let's take the first problem, which is the most repeated one. If you see, it has this exact problem has been repeated in these 3 papers over here. Let's solve that. And we're talking about group data. And we have been asked to find the 3 things: the mean, the standard deviation, and the coefficient of variance. Okay, let's attack it one by one. And that itself is a clue for you where they're asking you to find this. So you just need to find in the same sequence. Remember when I said MVS? So they're asking you to find the mean first, then the standard deviation. But to find the standard deviation, we need the variance. So we are going to find the variance, and the last is the coefficient of variance. So that's the sequence you need to find. So I'm going to plot this graph, or I'm going to plot this values in this table, not the graph. So we have a class, which is class interval, and then we have a frequency. Assume that at the bottom we have students and the top we have the marks. Let's think about in that perspective. So I'm going to write whatever is given to me as it is in a column format. See, if you see here, whatever is given to me, I've written in this 2 kind of row, whatever is given to me, and this is my frequency, the number of students. Let me scroll up a bit. Okay. And the first thing I'm going to do is I'm going to find the mean. Okay. First thing I'm going to do is I'm going to find the mean. That's my first step. But for finding the mean, since it's a group data, what does it mean? In terms of what does it imply? 3 students have got marks anywhere between 0 to less than 10. So it could be 0, but it's definitely less than 10. Okay, like that. So the marks are like this. X could be equal to or 0 could be equal to or less than X, it should, okay, hold on, let me back out. The student could have got a 0 mark, but definitely less than 10. So it could be anywhere between 1 to 9, 0 to 9. And that's what it is. But we don't know how many marks each one of them got. So what we do is we take the midpoint of this class interval 0 to 10, which is 5. And we assume each of the student exactly got on an average that exact midpoint score for calculation purpose. So if you see here, the first step before calculating the mean, what I'm going to do in the interim step in red, I put an asterisk, is to calculate the midpoint of each of the class interval. So these are the class intervals. For 0 to 10, the midpoint is 5. For 10 to 20, the midpoint is 15, and so on and so forth. So I calculate the midpoint. And now I have the students over here, and I have a midpoint mark, which I'm assuming that this is what each one of the students would have scored. So every student in this class interval would have scored 5 marks. I'm assuming that. That means for 3 students, it's going to be 3 into 5 is equal to 15. So one student scores 5 marks. For 3 students, I just need to multiply that. Similarly, 5 students on an average have scored anywhere around on an average 15 marks for this class interval. So it's going to be 5 into 15, 75 marks will be the total marks for all the students belonging to this class interval. And that way now I have the total marks, which is the sigma x into frequency. So this is the f into x because I'm multiplying the frequency and the x, and then I'm adding all of them, and that's where the sigma sign comes, the summation. So the total marks for all the students put together is 440, and the total number of students, which is the total number of frequencies, sigma f, is 20. So my mean is going to be 440 upon 20, and which is what I've written over here. If you see here, mean is going to be 440 upon 20, and which is going to be 22, and I've written 22 here all over the place for reference purpose. Okay, so that's my first step. So I've got my first step, and if you see here in the rules that I put, that's my first step. Okay, see here the rules. Calculate the regular mean or average, as we know, using the midpoint method. Okay, so that's my first step for group data. Okay, I've completed this. This is my first step. The next step is I'm going to calculate the individual deviations, because we need to calculate the standard deviation. So for that, we need to do the individual deviation. And like I said, for individual deviation, always remember individual deviation is nothing but kind of, if you plot the marks on the number system, what we are saying is how far is the student on that particular marks from the average. For example, if this is my number system and this is my 0, so my mean is 22 here. So let's say this is my 22 mark. Okay, this point is 22 on an average. Okay, or mean. Okay, and I know three students. I know three students over here have got 5 marks, right? And let's say this is the 5 marks range. Okay, for 3 students. So I'm asking how far is the deviation of this particular number, this particular 5, from this particular mean. So what is the difference between, on a number line, between this number 5 and 22, which is going to be 5 minus 22. That's what we're going to get here. And that's what I put here, x minus the x bar. X bar is the average, the mean 22. So that will remain the same, and x will keep changing based on this purple color. And the answer is going to be minus 17. And that's how I'm going to calculate the individual deviations for all the students. And again, these individual deviations are per student. That means on an average, every student belonging to this class interval is roughly negative 17 or 17 marks absolute from the mean. Okay, this is per student. This difference of 17 is per student. Okay, and if it's for per student, and then we need to calculate what will be it for the total students. We'll come to that. Okay, so we have calculated this, and we know that we need to get rid of this negative value. And for getting rid of negative value, we are going to find the variance by squaring it. This is what we do here. If you see here, we are squaring this value, x minus x, the whole bar, we are squaring it. And that way we are working towards getting the variance, or yes, the variance over here, if you see here. And when we square it, the negative value disappears and we get all positive value over here for each one of them. And since this squaring of variation from this individual deviation is still for one student, like I explained, we need to still get the total deviations for all the students in this class interval. In this class interval, we have got 3 students. And if this is the deviation for one student, and then we have squared this number, then for all the 3 students, it's going to be this number multiplied by the number of students, which is 3. If you see here, we are taking the squared difference and multiplying it by the frequency to get the deviations for all the students in the class interval. Okay, and this I have highlighted in red color and put an asterisk because this is the most important step when you calculate the group data, because often you will forget doing this. Because what happens is, when you're trying to find the standard deviation for ungrouped data, you stop here and you start adding the numbers here itself. All these things you add. Let me get rid of some of the things. Okay, so if you see for ungrouped data, you stop in this step. Okay, you stop here, and from here we directly get the variance. So we don't use this particular column. We just add this and then divide by the mean. But when it's a group data, we should not forget to multiply this multiplied by this multiplied by the number of students, the frequency. So this figure has to be squared and then multiplied by the number of students. We need to add that. That's the most important step in this whole process for group data. So do not forget that. Always multiply the individual deviations, square it off, and then multiply with the number of students. Or you can multiply this with the number of students and then square off. It does not really matter because it's just multiplication. Okay, so most important step. Just want to make sure. That's the reason I put this in red color. And I myself have missed it many times, and I will calculate in a hurry. So don't do that. For group data, be cautious. These 2 steps, finding the midpoint and then calculating the deviations for all the students, basically multiplying by the frequency, is very important. That's the reason I put both the things in red with asterisk. So 2 important steps, and that's the reason I'm covering this group data for standard deviation in a separate video. And once you get that, then it's easy. What I need to do is I'm one step closer to finding the variance, which is by this formula. So I need to add all the deviations for all the students for each of the class interval. That means this plus this plus this. I'm going to add all of this, which is what I get here, 2220. But if you see this, I'm adding it with the summation symbol, and then I will divide this number by the frequency, which is 20 over here. If you see here, I'm dividing the numerator. This is my numerator, 2220, and this is going to be my denominator. So if you see here, I'm dividing this, and the answer that I get is a variance, which is still a squared number. Always remember that variance is always a squared number because you got the squaring from here. It's a squared number. And for standard deviation, we need to take the square root of this number. If you see here, square root of this number, which is 10.53. So the final answer that we are calculating here, if you see, the first step is to calculate the mean, which we calculated as 22. The second step was, or the second ask was to calculate the standard deviation, which we have calculated based on the variance, which is 10.53. And the last step is to calculate the coefficient of variance, which is nothing but applying a simple formula over here, which is nothing but standard deviation over mean is your variance, is just coefficient of variation. And for percentage, you need to just multiply by 100. So if you see here, I'm getting this, both the things from the above table, 10.53 upon 22. This is my 10.53 over here. And then I get 22 from here. And the net percentage for CV is going to be 47.86%. It's a percentage, do not forget that. And that's how we kind of solve this problem, where we have found the mean. The first ask 22 units, because it will have some units. SD is again 10.53 units, and CV will not have units because it's a ratio of 2 units. They get cancelled. This and this gets cancelled. So no units. And since we multiply by 100, we are going to express that in terms of percentage. And in textbooks, if you see, or any solutions, they will put some statistical formula which is very compact, fx and divided by x square. In that case, you will have to mug up that formula. So don't do that. Just keep it simple. Like I said, follow the MVS rule. Find mean, then variance, and then find standard deviation. So find the mean, then the variance, and then the standard deviation, and keep these two things in red in mind. And that's what I have put here in the steps. If you see, calculate the regular mean as the first step, then calculate step 2 is individual deviations, then square those differences, and again this thing in red, where you need to multiply this value by the frequency for the group data for the class interval, so that you get the total square differences. Then you add up the square differences divided by the mean to get the variance. And in the last step, you take the square root of this variance to get the standard deviation. So this is kind of, I've written that as a cheat sheet in case you want to remember, and that's how you need to find the standard deviation for group data. Let's solve the second problem for winter 2019. Again, same pattern, no changes. That's why I'll just go fast, except for the change in numbers. Okay, so we need to find three things, the same stuff: mean, standard deviation, and coefficient of variation for this following data. Again, this is going to be group data because you have class intervals, and then you exactly do in the same sequence whatever I've done before. Again, two important steps is, first you need to find the midpoint for this class interval, and the most important step is, do not forget, once you find the individual deviation, then you square it off to make it positive. Make sure that you multiply this figure by the frequency for the students in that class interval, so that you get the total squared deviations for all the students in the class interval. Do not miss this step. This is the most important step. Okay, that's what I repeated. And rest of the things is very simple. The same rule that we are following. First, we are going to calculate mean, the M. Then we are going to calculate the V out of the MVS. And then finally, square root of variance is going to be S. And then after S, we'll find the coefficient of variation at the bottom. If you see here, we have found the mean, which is 25. Then the SDS 12.64. You can write units if you want, or you can leave it as it is because it will have some units. But the coefficient of variation will always be in terms of percentage, because the units get cancelled, because this is the ratio of this and this, so it gets cancelled. And then you get a value in terms of percentage, which is called as 50.596%. That's how you kind of calculate that. All right, so with that, we come to the last problem of this variation, and this is going to be the summer 2019 problem. I think that's the most trickiest problem. What I'll do is I'll cover this in a separate video so that you can get complete attention, and we'll focus on this one. So just watch out the last sub part of this part 5. Maybe I'll call this as part 5A. I'll just put this as part 5A, and the last video I'll put as 5B for the one problem. Just look at that, and that should be a wrap up on this topic, as well as coming closer to the whole syllabus on statistics. So I'll see you in part 5B.